Hey everyone, welcome to today's coding session. Today I'll be solving the course schedule problem using Python. I will explain the problem statement, its constraint, and the efficient approach we'll be using. We will explore two methods, the depth first search, which is a recursive approach to the text cycle and the prerequisite graph. And we'll use topological sorting, which will be breadth first search, and the Kahn algorithm. And when we use breadth first search, it normally uses a queue. This algorithm is a more intuitive way using in-degree tracking to process courses in the correct order. As I code, I'll explain each step, how we detect cycle, and eliminate unnecessary checks. And here is an example of our topological sort. And me here, I'm giving you this graph in order to distinguish between breadth first search versus depth first search. So here's the problem. We are given num courses labeled from 0 to num course minus 1, and an array prerequisites, where each pair, AI, BI, means course AI requires BI to be completed first. We need to determine if it's possible to finish all courses. So here's the key takeaways. This problem is essentially a cycle detection problem in a directed graph. If there is a cycle in the prerequisite structure, it is impossible to finish all courses. And if the graph is acyclic, we can complete all courses. So here's an example walkthrough. We have two courses, in this case 1 and 0 being the two courses. 0 is a prerequisite for 1. And because that's all we have, yes, we can take these courses without having a cycle. In this situation here, we got two courses again, which is 1 and 0, and we can see 1 and 0. 0 is a prerequisite for 1, and 1 is a prerequisite for 0. So we already know that's a cycle, because there's no place to start. It's almost like having a circle. In order for you to take 1, you must take 0. In order for you to take 0, you must take 1. So no, it's impossible for us to complete this course because there's nowhere to start. Now the constraints. The number of courses ranges from 1 to 2,000, so our solution must handle large input sizes efficiently. There can be up to 5,000 prerequisite pairs, meaning the graph could have large numbers of edges, requiring an optimized approach. Each prerequisite pair consists of exactly two elements, AI and BI, where AI depends on BI. And the courses are labeled between 0 and num courses minus 1, ensuring all indexes remain within a valid range. All the pairs prerequisite are unique, so no duplicate dependency exists, simplifying our graph construction without needing extra checks for repeated edges. Now we're going to start with the brute force approach. A simple approach to solving the course schedule problem is to check for cycle in the course prerequisite graph. If a cycle exists, it means we cannot complete all courses. So let's implement the code. Alright, so first we're going to call the collection default dictionary because we're going to need a dictionary. And now we're going to actually create the graph using that dictionary. And that dictionary is going to be a list. Here we're going to go through all the courses, prerequisite, which is where all the courses are given to us. And here what we're doing is we are given course, so that's going to be the key, and we're going to append the prerequisite to it. And here what we're doing is we're going to initialize visited with 0 originally based on the number of courses. So there are 3 states that we can possibly have. One is going to be unvisited, and that's where we have everything initialized to 0, which is where we're starting off right now. Then there is visiting, in which we're going to mark it to 1 to show that we are currently visiting that. And then 2, which basically means that we already completed that cycle and we didn't see any cycle. And here we're going to go through all the courses, initializing course to 0. In this case, what we're doing is course is going to be initialized to 0. Here we're going to call hash cycle, which means this is where we're going to detect if there is a cycle. If this returns true, that means that we're going to return false as a way of saying that there is no way that we can do the course, and that's because there's a dependency. That's what hash cycle is trying to figure out. Is there some sort of cycle? And at the end of the day, if this function returns true, this is going to return false as a way to say there is a cycle. There's no way we're going to be able to take all the courses that we're given. So if we're given 4 courses and then we see that there's a cycle, because there's a cycle, we're not going to be able to take all 4 courses. Now, in the event that this right here, this loop terminates, meaning we go through all courses and we find that there is no cycle, then we're going to return true, meaning yes, we are able to take all 4 courses because there are no cycles. So now let's actually implement the has cycle function so that we can see if there is a cycle. And here we already called the has cycle first. Here what we're checking is, okay, so we return 0, so visited 0, does it equal 1? Since this is a first call, we know this is going to be false. But if it was true, it's going to return true, which will make this right here say yes, there is a cycle, which again says we're not going to be able to take all the courses. And in this case over here, what we're going to say is, when we do the hash cycle, first we check if we visited the first time, and then we check if we visited the second time. Now, if we visited the second time, that means there is no cycle. We completed, we went through all the courses, and we didn't find a cycle. So that's going to return false, which at the end will show that this is going to return true. There is no cycle. We're able to take all courses without a problem. This right here is where we're going to initialize visited courses. So originally our array is showing like something like this that we have not visited. And this right here is going to change it from 0 to 1 as a way of saying that, okay, we're currently visiting this this node, or that we're currently taking this course right now, checking if there's any prerequisite. We're going to check the graph itself that we initially initialized over here. And we're going to start, let's say it was 0, I grab 0. We're going to initialize prerequisite with the prerequisite for that graph. So if we were given, let's say, an array that said the dictionary would be 0, 1, 0 being this portion, which would be the key, the course, and the prerequisite being 1. And that's what we're going to give to this. And then we're going to call it using the prerequisite, the hash cycle, meaning we're going to have a recursive call take place here. And if this returns true, then this is going to return true. And this is basically telling you in this case that yes, there is no way that we can take all the courses because there is a cycle. And in this case over here, in the event that we go through all the prerequisite of graph and we find that there is no cycle, then we're going to return, visit is going to equal to 2. And remember, this is a depth first search. So once we're done with this recursion, eventually we're going to come back up the tree. So this entire process, we were going down the tree every single time we were doing this recursion. Now we pretty much completed this recursion and we found out there is no cycle. So now we're going to initialize it to 2. So when the loop pops back up to the tree, so it goes from level 2 to, let's say, level 1 of the tree, then it comes here and it says, okay, did we visit this again? Yes, this is the second time we visit it, and it's going to return false. Again, this means that we are able to, for that specific course, the prerequisite does not repeat more than once. So yes, we're able to take all the classes up to this point. All right, so let's run the code. Let's see if it passes the test. All right, so it passes case 1 and case 2. And it has a decent run, 6 milliseconds. It beats 86% of coder. And by the way, sometimes LeetCode doesn't always give you, depending on how often you submit it, it could give you 11 seconds, 15 seconds. So this time isn't always going to be accurate. This time around, it's actually beats 86% of others. Now let's go through a quick example of how this code works. So again, this is a different code, but gives you the same exact feedback. So first we're going to initialize the graph, and we're going to base it off of the list, because we're creating a list. And the reason we use the list is because it gives you more efficiency and lookup. Anytime you look up in a list, it's about big O of 1. Number course is 4, and this is our prerequisite example. Currently, we're going to initialize this as an empty graph. Then we're going to loop through all the prerequisite, and again, the key is going to be the prerequisite, and the course is going to be 1. And that's how it's given right here, where the key is used as the prerequisite and the course is used as the value. Key, value. And now we're going to initialize the visitor to keep track if we visited this before. Again, there are 3 options: 0 not visited, 1 visiting, currently exploring it, and 2 process. We fully explore, there's no cycle found. Now here we're showing, we went straight from over here after showing initializing the visitor all the way to 4 courses, because now we're going to go through the number of courses starting at 0 to n minus 1. Courses being 0 now. And now we're going to call our first stack, calling cycle at 0. And here we're showing you graphically where we're at. So this is the first course we're taking. And then when we do take this first course, we're going to see, does it equal 1? We know this is a first time visitor, so that's going to be false. That's also going to be false. And now we increment this, we're going to increment it to 1 to show that we just visited, or we're currently visiting it. We mark it to blue to show that we're currently visiting it. And now this is where we would be at right now, where we're looking at graph course, which graph course equals 0, because course equals 0. And then that's going to give us the class that we're taking. So 0 is the prerequisite, 1 is the class. And now we went from 0 to 1. Again, we're going to see, okay, we're going to call half cycle, so we're engaging in our recursion. And in this case, we're passing the number 1. Have we visited this before? No, we haven't. Have we visited twice? No, we have not. And now again, we are going to increment, or this right here, from 0 to 1 to show that we're currently visiting this node as well. So now that we visit it, we're going to go again in the loop, and we're going to go and say, okay, well, 2 is currently so the course is 0, meaning the overall we started with 0, but our prerequisite is 1. So this is our prerequisite, and that's going to return our course 2. And that means that we're basically going to visit the next course. We're going to take the next course. And then again, once we check the next course, we're going to call the cycle. And now we're at cycle 2. And at cycle 2, did we visit it? No, this is the first time visiting. Did we visit this? No, this is the first time visiting as well. And again, we're going to increment index 2 over here as a way of saying we're currently visiting this course, or taking this class right now. Okay, so now we finish 2. And again, we're going to initialize graph course being 2 at this point. Since that's 2, now our course that we're going to take is 3 for prerequisite. We're going to call hash cycle recursively down, since we're doing depth first search here. And again, we go from 2 to 3. And have we visited? No, we have not. Have we visited this? No, we haven't. And now we're going to finally mark down this array to show we're visiting this course now. So we went from 2 to 3, meaning course, the graph course, when we put 2 on graph, is going to return 3. This is the prerequisite. This is the actual course. And again, now here we're showing, okay, we're visiting this class, or we're taking this class. And now we're going to call half cycle based on the fact here that when we put 3 on the graph course, meaning the prerequisite, which is 3, which this is the key, the value is going to be 1. So that means that we're going to go back up to this cycle over here. We're going to have to recurse back up. And that right there is showing you already that we do have a cycle. which means that we're not going to be able to take all courses because we're going to basically go again 1, 2, 3, 1, 1, 2, 3. So we're never going to be able to finish all 4 courses because we're stuck in a cycle. Is what this is telling you. So now this is graphically us representing it. We were here, now we're here. So again, we're going to go from 2 to 3, 1, 2, 3. So we're going to be in a cycle. So again, we're not going to be able to take all courses because there is a cycle. And this is where we verify it. Have we visited this before? Yes, we have. As you can see, this is red, and this red has 1. And again, we went back to this part where we already have progressed through it. So that's another sign that we are in a cycle. So this will return true, which is going to go back down here. And yes, this is saying no, it's not possible for us to take all 4 courses because there is a cycle. I hope this walkthrough helped you understand how to efficiently determine if all courses can be completed using the depth-first search cycle detection approach. If you found this valuable, don't forget to like, subscribe, and stay tuned for more in-depth coding tutorial. Now let's explore the optimized topological sorting approach, which is a breadth-first search algorithm, also known as Kahn algorithm, which provides a more intuitive and efficient way to solve this problem. So, all right, let's go through this breadth-first search solution line by line to understand how it solves the course schedule problem. Let's implement the code here. We're going to keep the graph because we're still going to need the node in order to transverse them. Now here we're going to use in degree instead as a way of saying that did we visit this course before we're using visited. Now we're going to use in degree, and that's because in this case we're using breadth-first search. And here, similar to our previous approach, we're initializing our graph. Our prerequisite in this case is going to be a key, and our course is going to be used as the value. And again, we're going to use in degree incremented to show that how many dependencies there are. That's what in degree is tracking. In this case, we are going to initialize Q. We're using a list comprehension. So here, what we're checking is if in degree every interval starting from 0 all the way to n-1, if it equals 0. What we're trying to find is our starting point. If it equals 0, that's where we want to start our loop for a breadth-first search. And here, we're going to initialize count equal to 0. And this right here is going to help us in order to find out if we are able to go through all courses. We know that there are however many courses they give us here. And we don't know right now, but we're going to figure out if we're able to go through all of them because this will increment from 0 all the way up to that. So this and that should be equal if we're able to take all courses. Now here, we're going to check, okay, is the queue empty? If the queue is empty, this will be false, and we're not going to run through this. And that pretty much means that we are not going to be able to take all the courses. If the queue has value in it, at least we have a starting point. In this case, this is where we're dequeuing, finding a starting point. If there is a starting point, this will run until this is still full. First thing we do is we're going to remove whatever value it is in queue, the starting point. So that course has the starting point, and we're going to increment count. So again, what we want count to equal number of courses. If that ends up happening, that means that we are able to take all courses without any conflict. There is no cycle. That's what this is saying. And here again, so we already checked in this case, okay. Graph is showing us all the courses that have dependency. And we're given whatever course number it is. In this case, the starting point may be 0. It's going to give us, again, if we had the example, let's say it was 0 and then 1. So if the graph is 0, we're going to return 1. And the next course we can take is 1 because we're only looking at courses now. And again, the next course is going to be looking at the degree. And whatever that array is, let's say it had 0, 1, 1, 1 or so. This is going to check, okay, we're going to remove it. We're going to remove it from here. So if it was 1, they'll take out 1, it's going to be 0. Now here is going to say, okay, well, is degree the same number equal to 0? If that's the case, this course is going to be appended to the queue. So this loop is going to continue. And this loop is going to continue until we go through each part of the array. And if we're able to go through each part of the array, this count will be incremented, and eventually count and num courses will be the same, and this array will be 0, which is another way of saying we're able to take all the courses. Now, if that does not occur, where count is incremented to equal number of courses, that means that we're not able to take all courses. And that's what this is. This is making sure it takes place. And as I said plenty of time, as count equals to number of courses, that's going to return true. And that means, yes, we're able to take all courses. If count does not equal the number of courses, that means that there's a dependency somewhere. And because of that dependency, we are not able to, actually there's a cycle. And because of that cycle, we're not able to take all the courses. Okay, so let's check out the code, see how it functions. All right, so as you can see, it passed both cases. Now let's see how it compares to others. All right, so as we can see, this one's even more efficient than the previous code, which was depth first search. In this case, this takes 4 milliseconds, which is 2 seconds faster, beats 93% of other users, and it's also more memory efficient. It beats 85% of other users. So this would be a better choice based on what LeetCode is showing us right now. This results, again, could change depending on how it runs on the machine. All right, so let's walk through a quick example. So again, as we did before, this is how we build a graph. First is an empty dictionary or hash map. And now we're going to initialize in degree to show if there's any dependency. Currently is 0. Now we're going to go through the prerequisite. As we can see, these are all the prerequisites. Course at this run 1 is going to be course 1 and prerequisite 0. Then we're going to add that to the graph, 0 and 1. 0 being the key, 1 being the value. 0 is a prerequisite for 1. We're going to increment in degree. And as you can see, now it equals 1. It used to be 0. And now we're going to move on to the next prerequisite. Course being 2, prerequisite being 1. We're going to add 1 and 2, 1 being the prerequisite, 2 being the course. Again, we're going to increment degree to 1. It used to be 0. And we're going to go to the next part of the array, 3 and 2. And we're going to add it to the dictionary or the graph. And again, we're going to increment in degree. And now we're going to do the same thing. Course is 1, pre-degree is 3. And we're going to add it to the graph. Now, as you can see, in degree equals 2. So that means there are 2 courses, as you can see here. The prerequisite, so the 0 is a prerequisite in order for you to take 1. And 3 is a prerequisite in order to take 1. So 1 has 2 prerequisites that you need to take before you can take 1. That's what this is telling you right now. And now we're going to look through the queue and we're going to find if there is any 0, as a way of saying any course that does not have a prerequisite. In this case is our first course here at index 0, has no prerequisite. So Q is going to have the value of 0. And this is a visual representation. We start off at 0. And we're going to initialize count to 0. Now is Q empty? No, it isn't. So we're going to be able to enter the loop. Now we're going to remove 0 from the queue. Course is going to equal 0. That's how we're going to initialize it. And again, that's how breadth first search works. We use a queue versus depth first search. We use recursion. And again, now this shows that we visited 0. We increment 1 count. It used to be 0. Now it's 1. Now we're going to go through the graph. As you can see, graph has course, which is at 0 here, which is a prerequisite, which will return 1. So next course equals 1. Now in degree, we're going to look at 1 over here, which currently is the value of 1. And we're going to decrement it by, no, it was the value of 2. And we decrement it by 1. So now it's 1. Because as you can see here, it used to be 2. Now it's 1. And now we're going to check, okay, well, is in degree equal to 0? No, it isn't. In degree right now, its value is 1. So it's not equal to 0. And now we know that the array, as we can see here, or the queue, which is an array, is empty. So that means there is a dependency, and the only node that we could have visited was 0. And because of that, we're going to return this. And we're pretty much just comparing it. Is count equal to num courses? No, it's not. Count is equal to 1, num courses is equal to 4. So it's going to return false, telling us there is a dependency. Okay, so here is the time complexity between the two. And this is big O. So big O, it's in general the worst case scenario. So LeetCode is not giving you the worst case scenario, it's giving you kind of the best case scenario today. So both cases, you can see, has the same time complexity and the same space complexity. So they're both pretty good at detecting cycles. So now what we want to know is when to use depth first search versus breadth first search. You use depth first search if you only need to detect cycles, and you use breadth first search, topological sort, if you want to process course in a valid order. Both approaches have the same runtime, as I said. So that's it for today's session. So if you enjoy watching this, please like, subscribe, and leave me a comment. Stay tuned for more coding tutorial, and happy coding.